Chapter 7, Lesson 1, Finding Square Roots. State Standard 8E2. You can see that we're doing this standard. We're going to use square roots. We're also going to evaluate square roots and perfect squares and cubes. We'll get to that. We're going to talk a lot about vocab today because we want to be able to identify perfect square roots, evaluate as well, and that's what we're going to be looking at today. Vocab. Square root, a number that, when multiplied by itself, equals the given number. A perfect square is a number with integers as its square roots. Now, I know that sounds like we should have an example with it, and I'll get there in a second. It's this little radical sign down here. This guy right here, we're going to be seeing a lot. Now, you're going to see me write it this way. And usually that's how I write it, depending on where I'm writing it and how, but it looks something like that. That's the radical sign, not the square root sign. We call it the radical sign. And then down here, you can see that this word radicand is the number underneath the sign. So for me right now, I want to make the radicand 4. What we see here then, it's asking us, what is the square root of 4? What number times itself gives you 4? 2. So the square root of 4 is 2. That's what we talk about, the square root. We were talking perfect squares is a number with an integer as its square root. So this is a perfect square because your answer over here is 2. It's an integer, not a fraction, not a decimal. So we talk about square roots. That's our answer over here, boxed up as 2, but we're going to have some sort of number, a radicand, underneath the square root sign, the radical sign. And what we're going to try to do is figure out what number times itself gives us that. Here's an example here. When we're looking at this, it says find the 2 square roots of 64. It's asking you what numbers, there are 2 of them, when they multiply by themselves give you 64. One of them probably jumps out to you for sure. But because it's your notes, please write the radical sign with 64 as the radicand, the number underneath of it. And what number times itself gives you 64? This is where you can just, if you're not sure, take a guess. 6. Well, what's 6 times 6? 36. Too low. 7. 7 times 7 is 49. Nope, not there yet. So 6, 7. Up next, let's try 8. 8 times 8. Oh, that is 64. Perfect. So one of the square roots is 8. In class, we'd have a discussion, but to keep notes moving along, the other square root, 8 times 8 gave you 64. Don't forget that a negative 8 times a negative 8 gives you 64 as well. That's where you have your answer. The 2 square roots, the 2 numbers, they're both perfect squares because they're integers. Now in my class, I'm going to use this sign, this plus minus sign, because our answer is a positive, a plus 8, and a minus or a negative 8. You can write them out, both 8 and negative 8, or you can just give me that symbol there. When we look at finding the 2 square roots of 121, what number times itself gives you 121? Well, when we're looking at the square root of 121, we have a positive 11 or a negative 11. So you could just tell me plus or minus 11. Now, on your assignment, if you're doing a book assignment or showing your work, please make sure that you remember in class I would talk about this is what I want to see on your assignment. I want to see that radical sign in the radicand, the square root of 121 equals plus or minus 11. That's all I need to see for work. Find the square root or roots. Notice it's plural. So up here in front, notice there's nothing in front of that radicand. Sorry, that radical sign. So what's the square root of 144? Guessing and checking using a calculator, knowing that from the table we have, it's 12. When you go down below, you can see right here, we've got that plus or minus sign, so it's going to want both of them. So it's talking about you want 9 and a negative 9, because it's both of them, the positive and negative answer, where again, in my class, Mr. Walls will allow you to use that plus or minus sign. So you could have just told me it's plus or minus 9. Please note again, on your assignment, do not just put down plus or minus 9. Mr. Walls is going to want to see the original problem and your answer, but that is all the work that I'm going to need to see. Up top, It's a decimal. Oh no! There's a way to show it in your calculator. If you need to see that, please ask me in class, or I might have a supplement video off to the side so that you can see how to do that on your calculator or phone if you're at home. But if you're not sure what that is, you can guess or check, or you can just type it into your calculator, and that's going to come out to be 2n 2/10, 2.2. Again, nothing in front, so we're just going to leave it as 2 2/10. When they give you a fraction, don't panic. Here we go. I'm going to keep that negative on the outside, and all we're going to do is we're going to distribute the square root, the radical sign, to the top and the bottom. What's the square root of 9? You're right, 3. What's the square root of 49? 7. You're right, because they're perfect squares, that's how we're going to work that out. But notice, our final answer, whether on IXL or math class, you have this negative sign up front that I copied down here. Make sure you copy that into your answer, that your final answer is a negative 3/7 in this instance. We're doing this because right now we're using square roots to solve or to evaluate what we're going to be doing next. Now, we've talked about the radicand, the radical sign. We've talked about square roots, so we could almost cross that off. We've talked about perfect squares. We're looking at those. We talk about power base and exponent as well coming up. But now, let's get into evaluating. Treat all the radicals as parentheses. So when you're thinking of PEMDAS, think of a radical sign as well as PEMDAS. So when you're looking here at A, I know you can see all of it there, but focusing in over here on A, are there any parentheses? No. Are there any square roots? Yes. Are there radical signs? Do that. What is the square root of 144? Well, it is 12. Don't forget what's happening between that 2 and that square root sign, that radical sign. There's a time sign, so if you need to put that there, please do. I'm going to rewrite everything so we can see it on one line. Are there any exponents? No. Then remember, multiplication and division. We're going to work left to right. Any multiplying or dividing, whatever you see first, do that. So I see the 12 times 2 gives me 24. Any other multiplying or dividing? Nope. So then again, same thing with these. Now we're looking for adding and subtracting, working left to right. Do whatever you see first. I see this. Final answer, -6. Done. Please note, I need to see all that. The original problem, I need to see on your homework, and then the work, and then your answer, step by step. Whether you want to write out each step like I did, or as I talked about before with that shorthand and just showing me your work that way, that'll work. If you have a question again on what that is, ask me and I'll help you out. Going in here, you're going to notice something perhaps quick. We're looking at the parentheses. So inside this parenthesis here, we're going to focus in on the only thing in there, the square root of 49. Well, that gives me 7. Great. Continuing out, I see that there is a power or an exponent on this base of 7. So 7 squared gives us 49. And copying down from up top, you had 49 minus 49 to give you 0. In class, we'd have a discussion about this right here. I'm just going to quickly go through it right now. Notice what happened. When we took the square root of 49 and squared it, we ended up with the same thing. So if you see that, you can technically just cross out that square root sign and the square. They will cancel each other, and you'll be left with the radicand, that number underneath the parentheses of 49, which we can see down here is what we ended up having. But you don't see it, that's fine. Go through the steps. Either way. Letter C, write down the original problem. Now, what you were looking at, there's 2 different ways to work through this problem. What I would do is look at 36 and 4. If they're perfect squares, then I want to leave them that way, and I'm going to distribute that radical sign, that square root, to the top and to the bottom. The square root of 36, well, that gives me 6. Square root of 4, that should be a 4 underneath here. I got a step ahead of myself. Gives me 2. Perfect. So now I've simplified that, but now I'm going to go back. I'm going to copy down that original remaining problem. So now I've got 6 2s, as sometimes said, but 6 halves, or 6 over 2 plus 1/6, please remember, in order to add You need common denominators, so I'm going to quickly change that into a common denominator of 6 by taking the bottom times 3. You don't need to show me this work, but I'm going to do it for notes purposes so you can see where on earth did the 18/6 come from by making that common denominator. From there, add the 1/6 together to get your final answer of 19/6, and in this case, since there is no ratio, you want to be very careful what your teacher, assessment, or IXL asks for. If it asks for a ratio, this is fine. If it asks for a fraction or mixed number on IXL, IXL will count 19/6 wrong. Please make sure that you switch that into a proper mixed number where 6 goes into 19 3 times. 3 times 6 is 18, taking that away from the top. That's where the remainder of 1 comes in. And we're going to keep that bottom number the same. So that is 3 1/6 as a final answer. The same as 19/6, just follow instructions, see what they ask. Be very careful because you know if you've been on IXL, if you get it wrong, they take away points, and we don't want you to get frustrated there. Ask if you have questions on how that final answer should be made. Now, when we talk about what is the radius of a circle with an area of 50 and 2400 inches squared, use 3.14 for pi. This is very important. This is going to help us out. We're going to use 3.14 for pi. Please remember when we talk about pi and finding the area of a circle, area is pi r squared. That's the formula. Make sure you write that on in here as well as on your assignment. It's a formula, so it's worth a point. Now we're going to plug things on in. It's got a area of 50 and 2400ths. It told us to use 3.14 for pi. I'm just going to leave my r squared here. Solve this equation. I'm going to solve by dividing by 3 and 1/4. 3 and 1400, so 3.14. From there, you're left with your r squared. 16 equals r squared, and this is where we're going to use that square root. We're going to use that radical sign, because what number times itself gives you 16? Taking the square root of 16, we're going to be left with, I'm going to write it on the right here, 4 equals r. So your radius then is going to be 4, and taking that label from up here, a radius of 4 inches. Find the dimensions of a square with an area of 324 square kilometers. Well, remember, the area of a square is side times side, or side squared. So when we plug that on in, the area was 324 equals side squared. To solve that, we are going to take the square root, because we're trying to figure out what number times itself is going to give us 324. What's the side length of the square that when we take and multiply them together, we're going to get the final answer of 324. That's where you're going to see the number 18. So the square has a side length of 18 kilometers, but notice it didn't ask for that. It said, what are the dimensions? This is something you have to be careful on a quiz assessment or on IXL. It wants to know it's 18 kilometers long by 18 kilometers wide. Again, we can see that we were working on evaluating perfect squares. We'll also just use that square roots to solve equations like this. So you can talk about the radicand, the radicals, square roots, perfect squares being taken care of, identifying perfect squares and evaluating them. That's what we're doing that today. Find the square roots of perfect squares, evaluate expressions, and use the square roots to solve equations.